How to choose the right foundation type. Choosing the right foundation is critical to the safety and longevity of any structure. Foundations transfer the loads of a building to the ground, ensuring the structure remains stable, even in challenging soil conditions. This decision is based on multiple factors including soil properties, structural loads, environmental influences, and construction constraints. Let's break down the key elements that influence this choice. Understanding the role of foundations. Foundations are the interface between a building and the earth. They support vertical loads, resist lateral forces, and control settlement. Without a properly designed foundation, even the most well-conceived building can experience differential settlement, cracking, or, in extreme cases, collapse. The purpose of a foundation is to provide a stable, durable base to distribute a structure's weight safely into the underlying soil or rock. Soil investigation, the crucial first step. Every foundation begins with a thorough understanding of the site's geotechnical properties. Soil investigation involves drilling boreholes, sampling, and testing to determine bearing capacity, how much load the soil can support without excessive settlement. Soil composition, whether the soil is clay, sand, silt, or rock, each behaves differently under load. A water table level, high groundwater can affect stability and influence the type of foundation required. Settlement characteristics, the likelihood of uneven settling, which can be critical for the structure's integrity. This data informs whether a shallow or deep foundation is suitable for the project. Types of foundations, shallow versus deep. Foundations are primarily classified into two categories. Shallow foundations. These include spread footings, strip footings, raft or mat foundations, and combined footings. They are used when the soil near the surface has sufficient bearing capacity. Shallow foundations distribute the load over a large area and are typically used for low to mid-rise structures. They are usually cost-effective, require less excavation, and are quicker to construct. Deep foundations. When surface soils are weak or when structures impose heavy loads, for example, high-rise buildings, bridges, or structures in seismic areas, deep foundations become necessary. These include pile foundations, drilled shafts, and caissons. They extend deep into the earth to reach stronger soil layers or bedrock and effectively transfer the load via skin friction or end bearing. Although more expensive and complex to install, deep foundations are indispensable for ensuring stability under adverse conditions. Key factors influencing foundation choice. Several factors determine the appropriate foundation type for a given project. Structural load and building type. Heavy buildings, high-rises, or structures subject to dynamic loads, such as wind or seismic forces, may require deep foundations. For lighter structures on strong soils, shallow foundations are typically sufficient. Soil conditions. The results of geotechnical investigations directly inform the decision. In areas with firm, stable soils, shallow footings or spread foundations work well. In contrast, loose or expansive soils necessitate deep systems to avoid excessive settlement. Environmental and site constraints. High water tables, seismic activity, urban density, or limited space can all influence the foundation type. Urban projects might favor shallow solutions to minimize excavation and disruption, while rural or coastal projects often need deep foundations due to softer soils and groundwater issues. A cost and construction feasibility. Budget constraints play a major role. Shallow foundations are generally less expensive and faster to construct compared to deep foundations. However, investing in a deep foundation may prevent costly future repairs if the soil conditions are marginal. Design considerations and engineering judgment. The decision process is not purely based on geotechnical data. It also involves design philosophy and risk tolerance. Redundancy and safety factors. Engineers design foundations with safety factors to account for uncertainties in soil behavior and loading. This might influence the choice toward a more conservative deep foundation, even if a shallow option appears viable. Construction method and timeline. The availability of specialized equipment and skilled labor can dictate whether a deep foundation is practical. In some cases, a hybrid solution may be employed, such as using pile foundations in critical areas and a shallow raft elsewhere. Future adaptability. For long-lasting infrastructure, foundations must be designed with potential future changes in load and usage in mind. This forward-thinking approach sometimes justifies a higher initial cost for a deep foundation system. Real-world applications and examples. Consider a mid-rise residential building on a stable, sandy soil area. Engineers typically opt for shallow spread footings or a raft foundation to distribute loads evenly. Conversely, for a high-rise office building in an urban setting with variable soil conditions and a high water table, deep pile foundations might be deployed. Projects like coastal bridges or seismic retrofits frequently integrate deep foundations to ensure long-term safety and performance. Conclusion. Choosing the right foundation type is a critical balance between soil conditions, structural requirements, environmental factors, and economic constraints. A careful analysis of geotechnical data, coupled with sound engineering judgment, ensures that the building's foundation will be robust and durable. Remember, the success of a structure begins at the ground level. Only with the right foundation can a building truly stand the test of time. Thanks for tuning in to Blueprint to Reality. If you found this breakdown insightful, don't forget to like, subscribe, and hit the bell icon for more engineering secrets and civil design tips. Until next time, build smart and keep exploring the foundation of our world.